Hello everyone. I wanted to start this series of videos to go over the problem project 18.1. I want to start by thinking through the problem and discussing how we can go about developing the solution. Then I will go and develop a sample solution. I wanted to mention first that project 18.1 and most of the other projects, these are problems that ask you to, number one, figure out a solution, number two, implement that solution using Java. Figuring out a solution to a problem, there could be many solutions, and in the design of the solution, I will refer to um, many different options in your problems. So what is this problem is asking you to do? Number one, it says that there is, and it doesn't define, it says that there is three data elements. There's a title, I'm sorry for my handwriting, and there's a length, and there's a color. And says that we want you to write a software that collects title, length, and color about something, whatever that thing is, and then present it to the user the collection that you gathered in graphic format. And there are two types of graphs. The first graph is a pie chart, which basically draws the different length as bars like this. And the other chart that asks you to do is a bar chart, and the bar chart will represent the same data, but in something like that. And I'm just here making estimates here. So if assume that you collected three data items, so this is the first, this is the second, this is the third. On a pie chart, it will look like this. So this is the portion of the first, the portion of the second, and the portion of the third. And I probably should erase this from here um, and make it a little bit bigger to be similar to what the other diagram showing. This is me being Bicky, sorry. Okay, so this is what the problem describes. So how can we go about solving this problem? And this is some thinking that we want to talk about. So the user, the way the problem would work is that the user will enter the data for each element in the collection. How many is the collection? We don't know. So the user will enter a title, a length, and a color about something, and then they come and enter another one, then they come and enter a third one, then they come and enter a fourth one. So as the user enters the data, the program needs to collect this data. And then the program displays the data in a diagram. Good so far? So that's what the program needs to do. So the next step is we want to ask ourselves, so what does the data mean? Let's take it one by one. Multiple questions we have to ask ourselves. The first question is what type of data? We are used to having data coming in one value. Like if you recall the data set example, or if you recall the midterm, there was only one data item. In the midterm, it was the grade. In the dataset example, it was the amount, whether it's an integer, whether it's a double. So one of the complexities in this problem, project 18.1, is that the data is not one value. The data is three values. So that could be okay. You ask yourself, so what type of data is this? If you remember back from chapter 2 or 3, we talked about two types of data. We talked about two types of data. We talked about primitive data, and there are 8 of them, the 4 for integer and 2 for decimal points, 1 for boolean, 1 for character. And then we talked about user-defined data. And we said that you can create user-defined data by creating classes. And classes has data attributes which represent its data members, and it has methods or actions which represents the behavior that should be performed on the data that the class represents. So primitive data, that's when you have only one value. Each primitive data item represents one value. So in the problem that we have here, we have 3 values. So the first thing that comes to mind, to represent those 3 values, you do not have any primitive data type to represent it. So the solution is to use a user-defined data type to represent it, which means that we will need to create a class. And I use this diagram to represent a class. This is called the UML class diagram. And you can call this class anything. Maybe you can call it data element. And then this class will have attributes. It will have an attribute called title. It will have an attribute called length. And it will have an attribute called color. And what methods this class should have. So this is the attributes of the class or the data that the class encapsulate, and then there are methods that or actions that the class uses. So in classes like this, whenever you have a class variable like that, you need to create the set and get method for each one of those variables. You need the constructor to initialize, and then any other specific method that you want. For this class, we don't really need any other method because the purpose of this class is just to help us keep track of the data. So the answer to this question then is that the type of data will be a user-defined type that we create, and we're gonna call it data element. All right? So the second question, so this is the first thing. The second thing is there is a collection here. There is a collection here. So not only we are gathering data that is from 3 different values, we're actually gathering a collection of this. So if we said that our data is represented by this user-defined type, we are in fact looking for a collection of this user-defined type. So the question that we ask ourselves next is how we want to represent this collection. So the second question that we have here is how to represent the collection. All right. So we know about arrays from chapter 7. And chapter 7 covers how can you represent a collection of classes that has more than one variable of the type. So our variable here is made out of 3 values. This is our variable, by the way, so that you don't get confused. Remember, we are using a custom data type. And we learned about some custom data types in the Java library called ArrayList. ArrayList is a very decent and reasonable class and data type to represent collections because it comes already loaded with some features. So to represent the collection, we actually can go many different routes. Um, you definitely need to think of a type that represent that collection. Now you can say, well, I'm going to use only the array list as the type, and that is very valid. Since the array list is already a user-defined type, you can say, well, my collection will be array list. Let's move on to the drawing, how we can go about drawing. You can also think that the drawing of the collection is in fact a feature of the collection, meaning what? This bar chart or this pie chart in themselves are different way of representing the same collection. So if I create a class that represents this collection, that class should be able to draw itself as a bar chart and draw itself as a pie chart. Think back to some of the other problems that we had when you want to print out something. If you want to print out something, the action of printing relies heavily on the data that you're trying to print. So one approach, and again I mentioned that there are multiple approaches here, is to create another user-defined type to represent the collection. So I come here and say, well, we create another user-defined type to represent the collection. So if I create my class diagram, and if I named my data type data element, maybe the other one I can represent it the data collection, for instance. Or you can call it data chart or data collection. You can name it whatever you want to name it. Now the attribute in this class will be a collection, and I'm going to use the array list to represent the collection, and it will be a collection of this data element. So it will be an array list made out of this data element classes. The data element. Okay, and what does this class should do? Maybe let me clean this a little bit. What does this class do? Again, in most of these, although I wouldn't really need it, but it's a good habit to have set and get for every attribute, have constructors to initialize. Then this particular class need a way to add a new element to the array. So every time we want to add an element to the array, we would call this method add a new element. The class also can have a method that draws the class as bar chart, and this is a method that needs to receive a graphics context to draw on it, and we can have a method that draws the class as a pie chart, and this one also needs to receive a graphics object to draw this pie chart. So now you see this user defined the class that we created. It does actually has some interesting actions or methods related to the problem that we have. So when you see something like this, you say to yourself, that was a good decision that we decided to create a user-defined type to group together all of these different actions that is concerned with this attribute. Now notice in the collection, we're using the array list, so we have only one attribute, but we have multiple methods here. Whereas in the data element class, we had multiple attributes and we had a smaller number of methods. So that answer the second question is how to represent the collection that you have. Now, the third question is that the program needs to collect the data. So how would the program collect the data, and how would the program display the data in the diagram? Now notice what we did here in the creation of the collection. We said that the data chart will have here a method to draw a bar chart representation of the collection and draw a pie chart representation of the collection. So how do we go about creating or looking at the collection of the data? The collection of the data leads us to ask a question about the user interface. Now we can, so far in our course, we used J option band, the input dialog. We used the scanner to read from the command line, from the user enter in a text or user enter in a dialog. And we started in chapter 9 and chapter 10 and chapter 18 talking about the event-driven programming. Event-driven programming, which calls on using graphical user interface components to collect the data from the user and to represent the output back to the user. So we want to use a user interface. If you read the beginning of chapter 18, you learn about different components. You learn about a component called JLabel. You learn about a component called JTextField. You learn about a component called JButton. And all of these components are important in gathering data from the user. So how would the user interface look like? If you think that this is the frame that we will create to the user, then this frame needs to have a mechanism to read the title, a text field to read the length, and a text field to read the color. Then, in addition to those three, remember in the J option band, the dialog, there was a button that we click on to inform us and that the user has already completed entering the data that it wants. So we need to add a button here to add the What happens when the user hits that button? When the user hits that button, we need to call on this add method, because this add method will take the data that the user entered in the text field and add it to this array method. So this will be the mechanism through which we will read data from the user. Now the second part is how can we display output to the user. The output for the user here, and there is an example in the book with the interest rate where the user enter interest rate and the program uses a text area in the space here to display and append the new balance based on the interest rate. So the similar concept, but the difficulty here is that you have multiple elements and you're not displaying text, you're displaying a diagram. So we would want to have a diagram that has our bar chart here, and maybe another one next to it, here that has the bar chart, the pie chart, and sorry for the Now, how can you add something on a frame? To add something on the frame, and we all remember that it has to be a J component. Remember when we created the cloud or the box or any of the diagrams, we had to create a J component because nothing can go on the frame except if it's a J component. So just as a reminder here that this is a J frame, and each one of those has to be a J component. Now, we are fortunate that the text fields, the buttons, the labels, all of these already exist in the Java library. So I can use them without making my own. But displaying the collection in a bar chart, displaying the collection in a pie chart, we don't have components like this. So one of the things that you can think of is saying that maybe I need to make a bar component and I need to make a pie component. Or maybe I need to make one component that has both diagrams in it. Now these are design decisions. You can decide which one you want to go with and decide and make your own design. I'm gonna go with two different ones here and we'll see which one I'm gonna use. The most important piece is that remember, whichever one you create, it has to have that collection. So the data chart will be important here. So we come to the realization that we need another class or two, depending on your design, and that class will be the component. So you can create, if you want to create one class, you can create one class that's called the maybe chart component, or you can create two classes, one class called the bar component and another class called pie component. The purpose of these classes is to represent the component of the bar chart and the pie chart so we can add it to the frame, and both of them has to inherit, back to chapter 11, has to inherit the class J component so that they are component and can be added. Now every class need to have attributes and has method. Both of them need to have an attribute which is this class, the chart class. So both of them need to have data chart as an attribute. So we'll say that they need to have data chart and they need to have data chart. And what methods should the class have? Well, you have a standard set and get. You have constructor. Same here. And the constructor. And if you go back to your previous studies, each class that's a component need to override the paint component method, need to override the paint component method. Okay? Now, these two components will be the components that we add here. So the other part we need to talk about is how about this frame. So this frame also will need a class. So it needs a class. This class needs to extend JFrame. So we can call this class chart frame. And this class will also need to have a data chart. This class will have a constructor to initialize the frame, and will have inner classes to represent the actions. On the mention of action, we didn't talk about how or when those two components will be displayed. So we said that the user will enter data, click the add button, and that will add this data to the array. You will say that, well, I'm gonna add these two to the frame, and when the user hit add, both of them will draw at the same time. Or you can say, well, I'm gonna add another button here that's called a graph, or whatever you want to call it, and when the user will have to hit this button in order to display these two. You may also come and say, well, I don't want to display these two. I'm going to create two option button where the user will select one of them, and when the user hit graph or add, based on the selection, only one component will be drawn at a time. There are so many different options, and you need to make your own decision on what you want it to have. This chart frame will need to extend the JFrame class from the library so that it is a frame and can be used. And you can see some examples to that, I believe, towards the end of chapter 11 as well as in chapter 18. So by creating all of this, the only piece that is left to us is we need to create an application class in order to initialize all of this work. So the final class that we need is an application class, which we'll call here chart app. And the chart app will have our main method. And what the main method will do is it will launch the frame, and display it. With this, we know how to do everything except the steps to draw the bar chart and the steps to draw the pie chart. And I covered the pie chart steps in one of the class sessions, and I covered the bar chart in the solution to the midterm. So you just grab the steps from both of them here, and you include that in the draw bar and the draw pie. So this concludes an overview of the problem. In the next video, I will start building this problem, going through the different classes from the beginning, the data element class, the data chart class, and then the that bar component class, the pie component class, the chart frame class, and finally the chart app class. Thank you.